Evergreens. We have a math problem.
And we need your help.
Over the past several weeks, we have been confiscating spinners here at EBHS. So far, we have a total of 3 spinners. Since that clip was filmed, I've been keeping track of how many spinners we've collected. This table shows the number of spinners we've had each day since I started tracking this information. Our goal today is to figure out what type of function best represents the data on this table. When I say go, take 30 seconds to silently and independently predict what type of function best represents this data. Go. And come back together in 3, 2, 1, time. I know this information is not represented by a linear function, but I can't remember why. When I say go, turn and talk with your partner for 15 seconds. Why does a linear equation not accurately represent this data? Go. And come back together in 3, 2, 1, time. Oh, that's right. Thanks for reminding me. Linear functions have a constant slope. In order for a function to be linear, it has to grow by equal differences over equal intervals. This means that if our input changes by the same amount, we should add or subtract the same amount to our outputs. From day 1 to day 2, we added 3 new spinners. But from day 3 to day 4, we added 7 new spinners. Therefore, I know this is not a linear function. So, if a function isn't linear, it has to be exponential, right? When I say go, turn and talk with your partner for 25 seconds. Do you agree that if a function is not linear, it has to be exponential? Why or why not? Go. And come back together in 3, 2, 1, time. Hopefully, you and your partners knew that I was wrong. A function can be linear, can be exponential, or it can be neither. So far, all we've determined is that this table is not represented by a linear function. Now, we need to see if it is represented by an exponential function. When I say go, turn and talk with your partner. Does an exponential function accurately represent this data? Why or why not? Go. And come back together in 3, 2, 1, time. In order for a function to be exponential, it has to change by equal factors over equal intervals. This means if we change the input by the same amount, our output has to be multiplied or divided by the same number. When we went from day 1 to day 2, our number of spinners doubled from 3 to 6. But when we went from day 3 to day 4, the same interval of 1 day, our number of spinners went from 11 to 18. So we did not double. Therefore, I know this table is not representing an exponential function. In this case, we have a function that is neither linear nor exponential.
Thanks, Evergreen.
We knew we could count on you.
How do I do the nose? Nope. Yeah.